Okay, we are there.
Can you see my screen?
Yes, we see your screen.
Yes, we can see.
Thank you. So yeah, this is my research. Also, it's titled as MicroNet Mapping and Monitoring Micro Ecosystems based on the US coordinate model using satellite images. So the thing that the research saw is the deforestation of mangrove. In my province, located in Ecuador, we have many mangrove ecosystems. They are decreasing each year, and as we can see here, the story area of the extension of mangrove, and in this figure, the type of coverage of mangrove and shrimp farms, as we can see, meanwhile, shrimp farms increase, mangrove extension decrease. But as the title of the research mentions, satellite images. So which satellites we're going to use is uh, three axis satellites. We are Landsat 7, Landsat 8, and Sentinel-2. All these satellites, they are all have the 6 same bands: the blue, green, red, near infrared, shortwave infrared 1, and shortwave infrared 2. So in order to start with the build our mode, we define this data as our inputs. So additionally, we have the spectral indices that are going to be calculated using the bands. As you can see, they are NDVI, NDVWI, NDMI, and MNDWI. And yes, they are calculated using the previous mentioned bands. But how we're going to do this? So yeah, this here's the how. First, we have the 6 bands. The in the research, I um, want to secure that every data sample has the 6 bands, and after that, to processing this data, we're going to apply atmospheric correction using CF mass algorithms and calculate the spectral indices. So our proposed model is going to use these ones, these 10 layers as inputs. We're going to use UNet, use for net, that is a variant of this not a variant, it is like a better version of the UNet, is concatenation, where we have the downsample, upsample, and in each layer, in each stage of the sample, the characteristics that our mode takes, they are concatenate with in each stage, and in the good thing of this is that we can detect, we can in this case segment every characteristic of mangrove landscapes. So yeah, this is the workflow framework. And as a final thing to mention is they are the metrics to used to evaluate the effectiveness of the model. In many previous studies about in mangrove, these metrics are used. They are over accuracy, precision, recall, and F1 squared.
Perfect. So we have already 5 minutes. Do we have questions? Arley, do you have any question?
Yes, I have a bunch. So first I have some comments about your talk also. So maybe let's make some comments about this slide. So first thing, I don't know if maybe I should send these comments written or should I just tell them like the.
Oh, written would be also good, but tell him it's also good.
So I think
Well,
some of these fonts are too small for me. I'm getting old, so I cannot really see small fonts anymore. So but one of my questions, like, so you're saying your model is based on UNet, right? And you never really told us why the UNet or U square net is a good model for this problem. So can you give us like a little, like, is this the best model you could have for this problem? Could you have a better model? Like, why did you pick this one?
well, there's a variant of U square net is whereas U square net, but I decided to use this model in specific because U square net allows it is mainly designed to um, object silent object detection, and in this case, we are going to use mangrove landscapes image as input. So in each stage of the user net, we can see the stage. The model predicts every detail of the pixels. So I found useful this model because many other studies also use it for for um, for mangrove mapping, but they only use blue, green, and red as their inputs.
Hmm, I see. And then the other question, like, do you have any results? Or you describe your talk ends when you're describing the metrics, but you didn't really show us, like, for instance, which accuracy, precision
Uh,
recall did you get?
as first results, first experiments.
Yeah.
Uh, no, I don't really have experiment. I experiment only with uh, uh, introducing these 10 layers as inputs. Um, we don't have early results.
Yeah, these are like submissions for the undergrad consortium. So we only evaluate the proposal of the research proposal. We don't ask them to have results. If they have preliminary results, great, but it's not mandatory.
Okay. Yeah, that helps a lot. Yeah. Thanks.
Yeah, but the idea is also that they start working with it, right?
Mm.
So I have a question for you, Jose. Have you already have the opportunity to work with the data or not yet?
Yes, I have worked with Landsat, Sentinel. In fact, the first image is extracted from Sentinel-2. Um, well, there is something to mention. I like to mention here is that this data can be less accuracy than for data that is offered by WorldView 4 and WorldView 3. That they are satellites that have restricted access, but they can be accessed sending a proposal for researching it, for this thing. And maybe we can send a proposal. Well, in fact, I was preparing a proposal, and if I think maybe we can send it in the next month or in the next weekend, the weeks, and if they accept this proposal, so they are going to offer access to better data.
Perfect. Thank you very much. Do we have any other questions? Because we already are with the time there.
One question, maybe in the future, not necessary to answer now. Uh, I don't understand what is the meaning of the output. I believe it's like a segmentation or something, but I don't understand the meaning and how are you generating or annotating that output.
Um, yes, the output is the objective of the output is segmented every image. So I forget what you mentioned, and Annotate, yeah, yes. For annotate every image, well, we're going to create that data.
Yeah, I only like to make it much more clear, yes, because if you need, I don't know, maybe you need to explain it to the US embassy or something, you have to explain in less technical words, yes? I don't know, you want to segment some regions or some places specifically, so that's only some suggestions.
Thank you.
Okay, perfect. Thank you very much, Josue. And we will let you know further things. Nice project.
Thank you. Thank you.
See
Thank
you.
you.
Nice to meet you.
Nice to meet you.
Bye.
Bye bye, Josue.
Uh,
Hello, everyone.
Hello.
Hi, we can
How
hear you
are
now.
you? Good to see you. Do you can you share your screen for your presentation or?
Yeah.
Okay, great. You can allow. Here with us is Professor Arley Lopez da Silva. He is professor at Computer Science Department at Rice University, and also is with us Eduardo and Niels, who you already know. So you will have 5 minutes for presentation, another 5 minutes for questions.
Okay. Please give me a few minutes. Nice.
Okay, ready?
Yeah, I am ready.
Okay.
Good morning or afternoon, everyone. Today I'm excited to share our research on improvement in Chagas disease detection in Latin America, generation synthetic image from blood samples using Singan evaluation in random forest models. The Chagas disease caused by the parasite Trypanosoma cruzi. It is spreading globally beyond Latin America due to migration and tourism. About figure one, the vector except transmits the Trypanosoma cruzi parasite 2 months in the time of a bit. Um, continues. El Chagas disease causado by the parasite Trypanosoma cruzi is spreading globally beyond its traditional confines in Latin America, largely due to migration continuing tourism, with 6 to 7 million people infected worldwide. And given the disease's potentially fatal consequences, our goal is to enhance diagnostic methods to address this public health challenge more effectively. Station 2, geographic scope and severity of the Chagas disease and problem. Specifically, this problem, this disease is about 5 countries: Brazil, Bolivia, Paraguay, Argentina, El Salvador. Enhancing Chagas disease detection using SINGAM. In addressing the limitation of current diagnostics practices, Our project employs single image generate adversarial networks, or SINGA, to generate high quality synthetic image of blood samples infected with Trypanosoma cruzi. SINGA is remarkable in its ability to produce diverse images from a single base image, capturing essential details like textures and structures specific to the Trypanosoma phase to the Trypanosoma cruzi. These synthetic images are then used to train and improve the accuracy of pre-existing random forest model, thereby extending our ability to detect Chagas disease even in regions where high-quality biological samples are scarce. In the pure illustration 3, it is about a single scheme.
Mhm.
This architecture employs a series of multi-scale generators and discriminators to learn for single images. This starting from the coarser level to the most detailed. Each generate receives noise and the output from the previous level to produce images that are progressively refined, while each discriminator learns to differentiate between the generated image and the scale real image. So this approach allows for the generation of the new image that retain the visual features of the training image.
Mhm.
In the illustration 4, it is about low sample effect with Trypanosoma cruzi. Trypanosoma cruzi, first Trypamostigote, through illustration A. B. Close up of the parasite body, presentation of the flagellum. It is a part of the body, the Trypanosoma cruzi. It is important for detection the Chagas disease.
Mhm.
And the moment and the time for detection the application of SINGA. Impact and evaluation of improved diagnostic techniques. To lay the use of SINGA in generating synthetic images for the diagnosis of Chagas disease, specific metrics. It is MCMC, CD, and CIFID. Specifically, CIFID, which is stable for datasets with fewer image.
Mhm.
These metrics will allow rigorous evaluation of the visual fidelity and diversity of the synthetic image, okay, to missing the training of deep learning models in diagnosing Chagas disease or machine learning. In a previous study, a random forest models was used to detect the Trypanosoma cruzi from Trypomastigote from the Trypanosoma cruzi in image captured with phone cameras.
Okay, Richard, I think I have to stop you here because the time already passed. It's an interesting topic. I would like to ask you, and maybe some other panelists here want to ask you, why it is important to study this Chagas disease? Why? Why
Can you
it
repeat?
is important? Yeah, why it is important to study this topic?
This the study is a topic is about implementation are single architect for detection Chagas disease.
Mhm.
Y to evaluate in about through random forest models.
Mhm. And why random forest models? Why are they important? Why to use random forest?
Because I was researching in the web, and so um, I I I find that uh, un research investigation about random forest models and application Trypanosoma cruzi. Other other thing important is the data set, the Trypanosoma cruzi is is I have it has few image few image.
Mhm. Okay, do we have another question?
Yeah, I have one question.
Mhm.
So, in your model, you're using, it's called Singan, right? Which generates from a single image. Why to generate for a single image and not from multiple images? Right? Like why, if you have multiple images, why would you use a model that generates a sample from a single image instead of from multiple images?
I don't understand. Maybe my computer uh, I it was some problem. The sounds from
Yeah, I can't repeat. So
yeah.
the
Thank
model,
you.
right, Singan, it generates image from a single image.
Single. Yeah.
But why to use just one image? Why not to use multiple images to generate? Right? Just why you need to generate it using a single image?
Yeah, what he's asking, right, is why you use a single image rather than multiple images.
The reason single and or the network generate adversarial network. Okay. Um, Single has capacity and generate image uh, about one image. So it it's important because data set that I have in this moment is I it have a few image. I haven't a full data set with image about Trypanosoma cruzi. Difference of other guns. Uh, the other guns have other guns usually a lot of image to and training the discriminator on generator.
Perfect. I think we are already out of time. So thank you very much, Richard. Um, it is it's a really nice topic.
Thanks, Richard. It's nice to meet you, Richard.
Bye. Bye, Richard.
Thank you, Richard. Bye.
Hello,
Hello, Jose. How are you?
good.
Good. I want to introduce you to Professor Arle Lopez da Silva. He is professor of computer science in Rice University, and also with us is Nils and Eduardo, who you already know. So you will have 5 minutes for your presentation and 5 minutes for questions. So whenever you are ready, you can share your screen.
Okay. Harley, nice to meet you.
Hello.
Hi, I'm Luis. I'm a computer science student at National University of Trujillo. I study in night cycle. I'm going to go to the presentation. And my presentation is implementation of all the spill in the Peruvian Sea for rapid location and cleaning using computer vision. Oil field has a high importance in society, but an accident occur, the rapid detection and rapid decision making prevent several ecosystem damage. In Peru, the low detection use cause irreparable ecological damage. How solve this problem? This approaches mitigates ecological and social oil spill damage by providing source of information for decision making. I use YOLO VH neural network to segment image of oil spill thickness color. Next, I get use cellular automaton to simulate oil spill dispersion. To train models, I use oil spill data image from RoboFlow. This provides 600 per 600 resolution image level by thickness color class. And thickness color are silver sheen, rainbow, and true oil. Next, to reduce noise of image, I use a bilateral filter. Then I get edge of speed area, and I join this image with linear combination. To improve the generalization model, I use brightness adjustment, add fog, and protection operation, and scaling operations to image. I choose YOLO VHSEC network because support instance segmentation and is lightweight mature. Also, YOLO VHSEC network use residual connection of different state of the network. This improves the model because provide information of different states of the network. Is each picture is a high level information. To evaluate the segmentation model, I use mini average precision model, but to solve imbalance data, I use F1 score method to maximize precision and recall, and use Gemini score to improve sensitivity and specificity about true positive rate and true negative rate. Finally, to measure the bounding post-regression, I use CHOU loss function. This loss function uses three important geometric factors: overlap area, normalized center point distance, and difference of aspect ratio. In conclusion, with this information, environment and agencies will be able to take action quite quickly. Thank you.
Thank you, Jose. Do we have questions, please?
Okay.
I-
Okay.
I have a question. Can you hear me, Jose?
Sorry.
Can you hear me?
No, you.
Can you? Yes. Is the audio working fine? Can you hear me well?
Sorry, I not here.
Can you hear me?
I can hear you, Arley. I don't know. Jose, can you hear Professor Arley?
I'm not here. No. Here. Repeat, please.
Can you hear?
I can
Jose?
check. Yeah. Can you hear now? Hello?
And there is noise audio.
Okay.
Mm.
Let us know if you hear us so we can ask a few questions.
Or maybe move like near to the router, or I don't
Yeah.
know if you have any issue there.
Or just stop sharing if you want. So you stop sharing. Maybe that is the problem.
Again, if it's
Jose,
Yes,
we can hear
Yeah.
you very clear now. Okay. So stop sharing. That may help.
sharing. Sharing.
Hello?
Hello.
Okay.
just can
Wait.
you make him stop sharing? I think you can.
Yeah, I can do it. Yeah. Okay. I don't know what I'm sharing, but and then I do this and then I do stop sharing.
Jose, can you hear me now?
Jose?
Yes, I from audio.
Yeah. Audio is fine now. I stopped your presentation.
Yes. So my question is, how does this project benefit your career? Can you tell us like how this project will benefit your career?
Uh, I use uh, I use this project because in my country has important marine fauna in the government that doesn't control or claim damage sea suffer. And in my career, we solve problem with digital solution. I use this project because a vision computer is the digital solution to solve oil spill problem in a city, in Peruvian city. And this approach will serve we maybe serve as source of information for ecosystem system restoring. If it is objective, this project is um, important because solve analysis, forecasting of oil spill, and maybe reduce ecosystem damage.
Mhm. Good. Jose Luis, which other projects have you been working on?
Yes, in my university, I work in projects in face detection and in face classification, and by in the exams of university.
Mhm.
Yes, other projects is um, in computer vision and hepatitis B prediction.
Mhm.
And other projects is cellular automata by dynamic system for COVID.
Okay.
Yes, for COVID. And other projects in computer and computer science in real time system to security to police patrol and for citizen security. Research, I work in project of dimension and proteins. And the project is healthcare home. And I use algorithms such as simulation annealing or genetic algorithms
Mhm.
to protein optimization.
Sounds like
This-
lots of work.
Now, now it's work in the project about neural graph with simulation algorithms to resolve protein problems. We combine a neural network with meteoritic algorithms.
Sounds good. Do we have another question for Jose?
I have one more question. It's about the data set. So the data set that you use has 921 images. Is that
Ah,
is that enough to train the model? Like, would you need more images? Or do you need a simpler model? Like, why is this? Because it seems like a small number of images. So what are your
It's
thoughts?
it's a small number because they are small small data set in the web. But I use data augmentation. I use operation such as business uh, uh, business operation such as protection, scaling, ad hoc. Because in the Peruvian seat, there are fog because it's cool temperature. And data augmentation improve the generalization of the model. And I use other metrics such as F1 score and Gmail score because they are imbalanced data.
Perfect.
Thank you.
Thank you, Jose Luis. Thank you very much, Jose Luis. It is a really nice topic and something that we actually should be working on in all these oil spills. It has been a pleasure. Thank you.
Thank you.
Thank you. Nice to meet you.
Bye.
Bye.
Bye. Thanks.
Okay.